Alright, so this is going to be an introduction to differential equations. So the first question we can ask ourselves, what is a differential equation? You're used to seeing equations like this guy, right? It's a very popular equation, something you're familiar with, y equals mx plus b. Or you might remember some kind of equation like this instead. Okay? So you're used to these. These are linear equations, okay? They both have a linear form to them. That's why we call them a linear equation, okay? Well, a differential equation is going to be one where it's got derivatives in it. So an example of a differential equation could be something like this guy here. Okay, and that's essentially what a differential equation is, okay? So it's unlike a linear equation. A differential equation is a derivative of the variable and the variable itself. And so in this case, I've got derivative, the first and second derivative of y. I don't have y in it, but this is a good example of a differential equation, okay? So one of the things we care about when it comes to differential equations is to ask yourself a couple of different questions. And one of the first ones that we care about, so we want to verify solutions. And so say that we have, let's do a reference equation here. Say we've got an equation that looks like this guy here. 5 equals x plus 3. And this is something you're kind of really used to doing, pretty easy and somewhat simple. Okay, so I could ask a question, is x equal to a solution, right? And that's pretty easy for you, okay? And then I can ask myself, is the variable x equal 1 a solution? Okay, this is a very low-level skill for you. Of course, you're going to say no on that second one, okay? Well, say we have a differential equation, and say it's this guy here, okay? Well, we can ask the question, and we'll do a couple of different examples here, okay? The first one is y equals sine x. Is that a solution? Okay. Well, now I go back here, right? The equation actually has the second derivative of y and y in it, okay? So in order for me to verify it, I actually have to find the second derivative. So I go and find the first derivative, right? Should be easy. Cosine x, right? And then we can go and find the second derivative, which should be easy now, which is now minus sine x, right? Okay. So to verify this, I have to put those back in. So if I actually throw those back in here in this example, I can go and do this. And so I got, minus sine x, right, is y double prime, minus y, which is just sine x. And then I ask myself, is it equal to 0? And the answer is no. Okay, so in this case, this one is not a solution. Okay. Similarly, let's just do one more example because it'll help us understand this a bit more. Let's ask the question, is this guy here, so y equal to 4e to the minus x, a solution? Okay, so we're going to use the same differential equation, and we can go through and check different solutions, okay? Well, same deal. I'm going to have to go through and find my second derivative, just like before. So the first derivative is going to be minus 4e to the minus x, right? And the second derivative, okay, is going to be plus, right? So I got to remind myself, and I probably did this quick, got to remind myself here, minus x, right? The chain rule on it, so I derivative 4e to the x would just be 4e to the x. But since I've got a minus x, it's going to be a minus from the chain rule there, okay? This time it's a minus times a minus when I do the second derivative, so it turns into positive for e minus x. Okay, so now I can go in and I can do the same thing. I could check to see if it's in this form. So y double prime for e minus x. Okay, and then the original one here, right, which is minus, and it's the original y, is this guy right here. So minus that, which is going to be 4e minus x, and then I can ask myself, is it equal to 0? Right, and I go yes. All right, so this one, yes, is the answer to this guy here. Yes, it is a solution. Okay, that's a very basic skill, and you'll see that in homework. It's a quick one. It's kind of like the same idea that this is a basic skill in terms of doing solutions here. Okay, I have down here general versus particular solution, and I'm actually going to go ahead. I'm going to go ahead and do that on a clean slate here. So what we mean by a general solution is the better way to think about it is this way. Okay, if I actually know some initial conditions, okay, and we'll talk more about that, then that will lead to the particular solution. Okay. If the initial unknown initial conditions, okay, then that leads to the general solution. Okay. What you're going to know, you're going to recognize this right away. So an example of a general solution, just so it kind of works really well, an example of a general solution would be something like, this guy here, y equals c e the kt. That's a good example of a general solution. And the reason why it's a general solution is there's a constant here that's unknown, and there's a constant here that's unknown. That's a general solution, okay? Just to be, complete, an example of a particular solution might be one like this, where after I know some initial conditions, then I can actually fill in those constants, and it could be something like this guy, doesn't really matter. Okay, and then that would be a particular solution. No longer do I have these unknown constants in it. And as we work through, you'll see these constants show up. There's a couple of really nice tricks with it that we'll talk about as we go through the course. Okay. All right, so let's do an example of a particular solution. So let's just say this is an example of a particular solution. Okay. All right, so we have the following differential equation. And we have some initial conditions. And we'll say that x equals minus 3. And we will say y equals 2 initially. Okay. Now later we will talk about finding solutions. In this case, we're just going to go ahead and say that the general solution of this is going to be y equals cx cubed. So we've got a c, a constant, in there, which makes this a general solution. All right, so then what we do is we're going to first actually do this in 2 steps. We're actually going to verify, because we did that just a little bit ago. Okay, we're going to verify that solution. So this is a nice thing for us to do, make sure we know it works. So, to verify the solution, back up the original equation, I've got a y prime and a y. Here's y, so I'm good. So now I actually need to find the first derivative, okay? So I go in here, and I'm going to find the first derivative of it. I'll do it over here. All right, well, let's see. So that's going to be 3cx squared, okay? Now what I can do is I've got a y prime and a y prime and a y here, so I can place those into the equation and see if it works, okay? So we're going to go and do x times 3cx squared minus 3 times cx cubed equals 0. And then if we work this out, this is going to be the same thing as 3cx cubed minus 3cx cubed equals 0. And yes, it is a solution. Okay. So then the second step, what we're going to do is we're actually going to go ahead and use the initial conditions and verify and find the actual particular solution. So we start with the general solution, and we have these initial conditions over here, right? So we can go ahead and plug those in. So 2 equals minus 3 if I wasn't such a loopy head, 2 equals c minus 3 cubed, right? That's the same thing as 2 equals minus 27c, and that means c equals minus 2 divided by 27, okay? Which means I can write out the final particular solution like this, right? So it'll be y equals, instead of c, now I can put in minus 2 divided by 27 x cubed, and now I've got my particular solution, okay? When we do a problem later, or when we do work with this later, we may not always verify the solution, okay? In fact, we actually may find the solution, okay? And then once we find the particular solution, if we know initial conditions, we will go through, know the general solution, we know initial conditions, we will find the particular solution. All right, so generally, if we're going to solve differential equations, differential equations can be really quite tough, okay? And we're only going to scratch the surface in a Calc 1 class how to do this, okay? And so generally what you're going to do is you're going to deal with these kinds of problems if they're separable. If they're separable, which will always work with separable, then we can use this general sort of tricks here, okay? First one is we can write out an equation from the word problem. So once we have a word problem, we can write out an equation from the information in the word problem. You will find that in some cases this will be pretty easy to do. Sometimes that's going to be pretty hard, okay? Other cases, we might just use a known equation, okay? I'm actually probably early on right now. We're just going to do a known equation, okay? And then second, what you're going to do is you're going to separate the variables. And what that means by separate the variables is very similar to what you would do in an algebraic expression. I'm going to put all the y's and its derivatives on one side. So if it has a first derivative, second derivative, third derivative, they're going to go on the same side as the y's. And then we're going to put all of the x's and its derivatives on the other side. So that's what we mean by separable, okay? This does work well when you have just two variables in the differential equation, and it doesn't have to be x's and y's, okay? Then you're going to integrate both sides, okay? And when you integrate both sides, in that case, when you integrate them, you might have a couple of tricks that have to come in, okay? But once you integrate them, then what you're going to do is you're going to solve for y or the variable of interest, and at that point you'll have the general solution, and if you have some initial conditions, you can get the particular solution, okay? So let's do a simple differential equation here, okay? And I'm going to follow these steps. So say I have this as a differential equation, okay? Y prime equals 2x divided by y, okay? First thing I'm going to notice here is I will want to go ahead and and separate this. So in here I've got my y prime, I've got a y. So I actually want to get these together. So this one's not too bad, right? It's pretty easy. So what I'm going to do is I'm going to multiply both sides by y. So I get y prime equals 2x. Now at this point I actually need to do a little side note here because something's kind of hidden here and it's going to cause me some issues if I don't catch it. Okay, y prime is nice notation, but it's actually the same thing as dy over dx. Okay, and I need to remind myself of that because actually that dx thing we've worked with quite a bit in this class, that's in the variable x, which means it's on the wrong side of the equation. It's over here. Okay, right? So if I rewrite this, I have this as y times dy over dx, and I have 2x here, right? So I've got that on the wrong side. So then what I want to do is go ahead and take and multiply both sides by dx. So I get y dy equals 2x dx. Okay? So, I should be kind of, at this stage what we're doing is we're still in the process of, in here, separating out the variables, right? I should kind of write that. That's what I'm doing, okay? Now, I can do the next stage. I can integrate. So I can integrate both sides. So I can integrate this guy, y dy equals integral of 2x dx. Now, I'm not going to be selling you a used car here. I say that sometimes in class. But it's kind of like what we do with equations. So if I integrate on this side, then I can integrate on the other side, and they're going to be the same process, okay? So I'm not trying to sell you a used car here, but I can integrate both sides, okay? Well, if I do this, and I integrate both sides, y dy, I know that's going to be, and I'm going to do this the way it should be technically, and then we'll do a cleanup step, and I'll mention an extra thing in here. So this is going to be what, right? 1/2 y squared, right, plus a constant. I'm going to call it C1, okay? On the other side, right, because this is indefinite integral, so it's going to have that constant. You want to forget that constant. On the other side, I'm going to integrate that, and that turns out to be x squared plus C2, okay? So at this point, I should probably still be good about this. What I'm doing here is I'm integrating. Okay, I'm going to use a clean page here in a second, but before I do that, I'm going to do one more step here, okay, or mention one more step here, okay. What I notice here is I've got a C here and a C here. Generally, most books, and your book will do this, and most people will actually just go ahead and combine these right off from the front, okay. I know I'm going to have a constant when I integrate on this side, doing an indefinite integral. I know I'm going to have a constant when I integrate this side, when I do an indefinite integral. And so what I'm going to do is I'm going to go ahead and I'm going to combine them. So you may see this step where if you write it this way, if you let C1 plus, actually clean that up a little bit. Okay. I should clean that up just a bit, sorry. What you're going to really get is C2 minus C1, and we're going to call that a constant. Okay, just C. Right, so I'm going to subtract C1 from both sides, and now when I do that, I'm going to call it just C. So I'll have 1/2 y squared equals x squared plus now C, because I'm substituting in for that. Okay, and one last step that I will do here is I'm going to go ahead and rewrite this as y squared minus x squared minus 2x squared equals C. Okay. Now on your final answers, sometimes you will find that you may write these a couple of different ways. Okay. In this case, I actually didn't solve for y. I'm going to write it as an equation here, mainly because I've got the squares in it, and to try to avoid this, square root of plus or minus square root of something. Okay. you'll probably have to pay attention on final forms. A lot of times I'm going to say y equals. In this case, this is a nicer way to do this simply because I've got the squares and this is a better way to write the term out.